Inequalities today. We've dealt with graphing systems of equations, where you find the lines and you figure out where they intersect, and that's your answer. So what we need to do with this is we need to look at, well, what if we have an inequality? Remember, an inequality, we make the dividing line, and then we shaded in part of it. But what you'll notice here, it says that the solution to a system of inequalities is all the ordered pairs that make it true. So it's the overlap. So you'd have one of the inequalities that's graphed and another that's graphed, and then you would color in the part that makes both of them true. Question? Okay. So as you take a look on your paper, we have a system of inequalities. And I've got the graph there so that you can take a look and you'll be able to graph those inequalities. And if you remember from before, we pretended that it was an equals. And then we did our graphing and our shading. So we want to look at this carefully. Now, don't take these notes in pen, because part of it's going to have to be erased when you get your final answer. So you want to do a very light job for your initial graphing, because remember, the answer is going to be the part that's overlapped. So we're just going to be working right on the notes, and we'll save our homework questions for when we get everybody back on Monday. So on here, this top one, y is greater than 2x minus 3. What can you tell me about what you think the process would be just for graphing this top one? What if it was an equals? What if it said y equals 2x minus 3? Yes. Y equals mx plus b. Good. So we pretend it's an equals, but what's different about when we graph it, because it's a greater than? We're going to be shading part of it. And what kind of? Good. And it'll be a dashed line. So we don't want to forget about those things. So when you go ahead and graph it, y equals mx plus b starts at -3 and then goes up 2 over 1, up 2 over 1, up 2 over 1, just like you're used to, and we make a dashed line. We would shade part of it. Some of you might remember that you shade above because it's greater than, or you can use a test point, plug in 0, 0, and because when you plug in 0, 0 to this, we get something that's true. It means we shade this side. Notice that I've got it shaded here, but I'm prepared to erase. So when you're putting this down on your sheet, kind of make very light marks here, because we are going to erase part of it because we're looking for where it overlaps, where it's shaded in on both of these graphs. So we've got this one here in red. I want to make sure everybody is caught up to that and understands. Then we'll be back in a second. The other one is just the same. We're going to have to treat it as if it's a y equals mx plus b equation. So where will we start on this one, and where do we go from there? If it's an equals, do we use a solid line or a dashed line? What are we thinking? Solid line. We start the graph at where? At 4. I heard somebody say 4. And then what's the deal with the -1/3? Down 1 over 3. Good. Down 1, right 3. So you'll start at 4, go down 1, right 3, and make a solid line on that. So that's our beginning part. And then we have to figure out, well, where would it be shaded? Is it going to be shaded up above or down below? You can make your pretty good guess just because you know about with the greater or the less, but we can confirm it by doing what? Test point. So we'll plug in our 0, 0. And do we find out that it's shaded up above or down below? Shaded below. If we plug in 0, 0 is less than or equal to 0 plus 4. So we shade below. Now the thing is, it's got to be the part that's shaded in on both. So when we begin to shade below, what we'll find out is that this piece right over here is shaded in on both. This is not, and then this is not. So we shade in below, but then we have to erase the parts that are shaded in on just one. So it's just this part that's got both the red and the purpley blue. This would be the region where the answers live, and these not. So we have to clean it up just a little bit. And oops, wrong way. And get rid of those pieces. So you're shading this part in. This is the part where both of these are things are true in this system. It's greater than 2x minus 3, also less than negative 1/3 x plus 4. And you've got your border lines there. And your answer is your graph. And it tells you the ordered pairs. All of the ordered pairs in this shaded region, if you plug them into both equations, would give you trues. Remember, the reason we shade is because it's giving you a graphical representation of where all of the right answers are. So there's millions of right answers, but there's also millions of answers that are not true. So these have to be unshaded in. And so we would be looking for that to be your final answer. Any questions? It looks like everybody's caught up. And some of you are looking ahead to the next one, so that's very good. Let's move on. So this one has a couple of different things going on in it. What can you tell me about this first one? What's the general shape of this one going to be? It's going to make a what? A line. Good. It's going to make a line. What's the general shape of this one going to be? A V. It's going to be that absolute value V. So we've got two things happening here. And then we also have the added challenge that we have to make this into something that's easier to graph. Any ideas about, for this linear one, how do we make it easier to graph? Y equals mx plus b. We have to solve it for y first. So let's solve this one for y and then proceed to do our inequality and our graphing. So go ahead and get y by itself. It'll take a minute to do that. 2y minus x less than or equal to 6. And our step would be to so our step on that would be to take 2y minus x less than or equal to 6. We're trying to solve for y. What do we do to both sides? Divide by 2 later. Add x first to bring the x over. 2y less than or equal to x plus 6. And then what? Then divide by 2. So this is y is less than or equal to, we need mx plus b form. Half x, good, there's a hidden 1 over 2, half x plus 3. So we have that. And then just in general, and I'll pull up the nice graph in a minute, but in general, if you're graphing it, where does this one start? At plus 3. And the 1/2 tells us go what way? Up 1, right 2. So you would do something like that on your graph paper. That's very nice. You'd have this solid line, pick our test point. This is just kind of a really quick thing, but just so that you see it happening. And our paint is just very nice for writing for this. So we plug in our test point. 0 less than or equal to 1/2 times 0 plus 3. Is this one true or false? Is 0 less than or equal to 3? Yes, so which way do you shade? Bottom, where the 0, 0 is. So right down here. And it looks like, where'd it go? Looks like this. Once again, I didn't shade it in very darkly because we're looking to see, we know we have another piece that we need to consider. So let's just think for a minute, we have this one. Absolute value, somebody already said it's going to be a V shape. How do I know what? Oh, these 1x, oh, I see, 1x plus 21, no, absolute value bars. So where's our vertex going to be? Who remembers that from the last? -2, -1. Good. Glad you thought that through. I didn't even have to correct you. You figured it out on your own. So -2, -2, -1. So down here, right? -2, -1. And then you need to make your V shape. So you're going right up in the corners. Some of you on your test didn't go up the corners. Some of you had a problem with that. So go right up the corners. It's going to be so that it's going to intersect just right here. So we're going to get the right region, and then up the corners this way too. And then you make your graph like that. Excuse me. And then there's a matter of where do we shade it. When we had a greater one, where do we generally shade it? Or where do we shade it? Not just generally, where do we shade it? Below it or above it? Yeah. What do we think, below or above? For this part of the graph only, just the V part, are we shading below it or above it? Above it, greater than, up above. If we did pick a test point and we plugged it in and we put 0, this is why I use the paint. So if we put in 0 is greater than or equal to, what was the absolute value of what? X plus 2, so 0 plus 2 minus 1. So we would have 0 is greater than or equal to 2 minus 1. 0 is greater than or equal to 1. So if we did 0 is greater than or equal to 1, that would be false, and that fits right along with what you said. It's just a second confirmation, because when we plug it in here, we get a false for this. So it wouldn't be here, it would be the other side, which would be above. So our graphing comes out to be above. And when we graph above, with these lines, we find out that the part that is shaded in below the line and above the absolute value function is this blue one right here in the middle. And then we need to erase the leftover pieces. So here's our answer, just this part shaded. Now, you don't like the process? The erasing and everything? Yes. Yeah, if you want to, like she said, you could draw them in first and then evaluate the greater and less than, and then maybe save yourself if you're mentally figuring out where things are shaded. Now do be careful, because if this just had a little change to it, okay, if this instead of being a less than was a greater than, it wouldn't be this little triangle in between, it would be this region up here. So do be very careful. Don't just expect that when it makes a shape that that's the part that's shaded in. It happens to be this time. So if you're going to draw them first and then evaluate, be careful what you're evaluating, because you do have to have both graphs correct to find out where the intersection is correct. Okay. Any other questions? You all right? Okay. All right. And another one. This one, the only thing that makes this harder is because there's 3 pieces instead of 2. So each one of these has its own thing. This one, can someone describe the shape? It's a V. And what's this negative tell us? Upside down. So it's an upside down V. So let's think about where it goes. This tells us it goes which way? Goes to the left 3, and it's an upside down V, so going down like this. And it's less than, so is it shaded above or below? Below, good. So we moved over. Do notice that it's a dashed instead of a solid. Left 3, just like we did before when it was an equals, you pretend it's an equals. We have to remember what the different things tell us. The negative tells us upside down. And then our shaded below, if we picked a test point, that could verify. If we pick 0, 0, 0 is less than -3, which would be false. So it's not up here, it's down here. But it is easy to think about the less than ones. As long as you have y solved for, the less than ones mean below, and the greater than ones mean above. That's your shortcut. So we've got that one. This one, what's our shape going to be for this one? A line. So solve it for y to get it in mx plus b form, and you get so y equals x minus 2. So y equals x minus 2. When we have that, you know how to graph that one. Don't forget what's the slope when you have y equals x minus 2. It's really giving me a hard time here. Y equals x minus 2. What's our slope? 1 over 1. So we'd start at -2, go up 1 over 1, get a very nice graph. Oh, we've got everything on there. Didn't mean to do that. I'm going to do this because that's just too much. I'm going to copy this. Let's select this and copy it. I'm going to put it on a paint screen. Copy, and we're going to put it right down here on a paint screen. Paste it on there. There we go. So we have this one. Doesn't give us the advantage of the background, but at least we have something to work with here. So you don't have to see it all the time. We had, what was our equation again? Y is greater than x minus 2. And so our minus 2 was here. And then we were going which way? Up 1 over 1. So like this, and then up 1 over 1. So it was here. And is it dashed or solid? Dashed, yes. Okay, so we've got our dashed line here. So let's go ahead and put this in. I can make this line here, and then I can make it dashed. You guys are in better shape with yours because you've got just your pencils in front of you. I can make it dashed. Sometimes you need to go back and just erase to make it dashed. That's what I'm doing here. And it's greater than, so are we thinking above or below? Okay, so since we don't know, let's check a test point. Let's check 0, 0. 0 greater than 0 minus 2. Is that true? Yep, 0 is greater than -2. So what we can do then is we think of it's going to be in this region where that is. So that takes us above. So somebody said not sure, so we want to make sure that we're sure that we're sure. Okay, and let's move on to the other one. We go above for that. And we had the other last one to do. This is just not working friendly. Here we go. Y is greater than -5. So we need to think and evaluate y is greater than -5. Greater than -5. It's a horizontal line, good. -5. So we have -1, 2, 3, 4, 5. So roughly down here, and he said horizontal line. So I can make a horizontal line that will be there. Okay, yours is better. So horizontal at -5. What do I need to make sure that I didn't do? It's dotted, so I have to do it by erasing, but you could do it. It's a dotted line. And then since it's greater than -5, where's greater than -5 live? Above that line. So just this way. So it's up like this. So where's our final answer live? In this place right here, right? And then we can look at the pretty one, but so that you could see it happening a little bit easier, it works better that way. So we've got right here. So remember, for inequalities, you have to graph each one, and you're looking for where they intersect, where everything is shaded in, and you get that one little region, so you keep track of it, and then you erase the parts that can be erased. And that's it as far as the presented material, but we are going to work on the practice ones here and take any homework questions that we might have.